Right, we're going to be having a look then at fuels that are used when we're talking about generating electricity. And the reason we're just going back over this is because of the gases that the fuels release and the effects this can have on the atmosphere. So let's just reiterate what we did in terms of the fuels used for generating electricity. First of all, can you name the 3 fossil fuels? You should be able to say that they are crude oil, coal and natural gas, and they have been made over millions of years of where dead animals and plants have been broken down and made into a kind of gooey soup, if we're looking at oil, squashed down to make coal and the gas that's released from them. These are put into a power station and they are burnt to release the heat energy. The heat energy boils the water, which makes the steam turns the turbine turns the generator, and this produces the electricity that is sent into the national grid. Now an alternate fuel, and this is something we're looking at a lot more, an alternate fuel is something called biomass. And if you think about the word, if you're not quite sure what it means, think about biology. So bio it used to be a living thing, and then mass is the amount of stuff that's there. So your biomass is the amount of atoms or particles present in something that used to be living. So we're looking at things like wood, straw and manure, which can be burned or fermented to generate methane, which can then be burnt, and the methane is a gas. Anyone that owns horses or know anybody that owns horses, they do actually collect the manure, and if they keep it in one pile, they can generate the heat from it and use that to heat up other objects, or they can actually dry it out and use it as fuel to burn. Fossil fuel supplies are running out, and we know that because it took millions of years to make the fossil fuels in the first place, and we are using them at a rapid rate. And also when they are burnt, they do cause pollution, including carbon dioxide, which is a greenhouse gas, one of them, and we'll be having a look at that in a second. If we go back and have a look at this equation, now this is something that can pop up at any stage where they ask you to talk about how efficient a fuel is. Now this equation came up in B2 as well, so they don't usually give you this equation on an exam paper. You would be expected to know it. So the useful energy output, so how much energy has been given out, divided by the energy that went in the first place. And because it's an efficiency, you must multiply it by 100, as it is a percentage. Now this is what I call one of those common sense equations, because if you work it out and you get some obscure number like 6,000 or 0.2 or whatever, then the chances are you've probably got it the wrong way round. So try and turn it around if you can't quite remember whether it's 8 divided by in or in divided by 8. Like I say, use your common sense on that one. Okay, so for instance, here's an example then. If a pendulum has 200 joules of energy, if it loses 25 joules as heat, calculate the amount of energy, of useful energy. So 200 take away 25 equals 175. The pendulum's efficiency is 175 divided by 200 times 100, because it's a percentage, and it would be 87.50. Please put in, if you get decimal places, please put in, if it's 1 or 2, I'd go up to 2 as a maximum, but make sure you put them in, because it does come up that you will lose marks if you don't. Okay, there's another example here. Gas power station burns a lot of fuel. So you can see, you can try and work out the efficiency of this. Okay, and there's the example worked out for you, and it comes out at 28.9%. If we have a look at this is to do with global warming, and I'm sure you've heard about global warming before. The atmosphere around our planet is essential for life. Not only does it contain the essential oxygen for all living things, we've already learned how it protects us from high energy ultraviolet radiation from the sun. So if you remember, the ozone layer absorbs the UV from the sun, and that is completely different to when we're looking at global warming, so please make sure you learn that. Our atmosphere also performs another important role. Most electromagnetic waves are able to pass through it. However, some wavelengths are absorbed. Some gases within our atmosphere absorb infrared radiation and prevent this heat from radiating into space. And this is called the greenhouse effect. Without this effect, our planet would simply freeze. So you can see from this diagram then, you've got the shorter wavelength electromagnetic waves from the sun that pass through the atmosphere, and as they get absorbed by the earth and the plants and everything else, they then give off longer wavelengths. And these longer wavelengths, some of them can go through the atmosphere and bounce and go into space, and some of them are absorbed, and then some of them are bounced back down. Now the problem we've got with global warming is the three gases for the greenhouse effect are water vapour, which obviously comes from the water cycle. We've got methane, which can come from animal waste, and also from intensive farming and extraction and burning of fossil fuels. And we've got carbon dioxide, and a source of that would be volcanic eruptions, waste product from living things, again extraction and burning of fossil fuels. Now because we are burning so many fossil fuels, the layers of gas above the earth are getting thicker, and so it means more of the waves are actually being bounced back down to earth and warming it up, hence the whole greenhouse effect, just like a greenhouse works. Okay, so like I said, the three gases there you need to remember. So if we look at climate change then, trees can absorb the carbon dioxide, and that's why it's so good that we've got so many trees, because they actually act as stores of carbon dioxide. The problem comes when we cut down lots of trees, deforestation, and then we burn the trees, and all the carbon can be released, so it goes back into the atmosphere, again raising the levels of carbon dioxide. Changing weather patterns means a change in rainfall, some more, some less. More flooding, so some countries have drought, more hurricanes, and human causes for this are the increased burning of fossil fuels, dust from factories, and dust from volcanic ash. And you will probably know that over the last few years we've started to see more and more of all of these things taking place. So biomass then is an alternate form of fuel that we have started to use. However, it can be used to generate electricity, but obviously we need the sources in the first place to be able to produce them. Okay, so advantages of non-renewable: the capacity to generate large amounts of electricity, comparatively inexpensive, very reliable method of energy production. Transporting oil and gas is easy, and that is an issue to think about. You know, how do you transport all these trees and how fast they burn? Fossil fuel power stations can be located anywhere, and fossil fuels are generally easy to find, getting harder as we are using more of them. Gas fuel power stations have a short start-up time, and they can quickly increase the amount of electricity they generate to cope with sudden increases in demand. Like for instance, if everyone's watching the final of Britain's Got Talent, then you're going to need a lot more electricity to be produced at that time. Disadvantages: burning fossil fuels gives off carbon dioxide. The mining to get coal out and oil damages the environment. Crude oil spills can cause environmental hazards, and there has been a couple of years ago a big spillage from a pipe in the sea, and BP were responsible and had to clean it up. Coal power stations need huge amounts of coal, and fossil fuels are going to run out.